Robotics ** and ** automation * are closely related fields that deal with the design, creation, and use of intelligent machines and systems to perform tasks, often with the aim of increasing efficiency, productivity, and safety. While they are related, they have distinct focuses. Robotics *. Robotics involves the development and use of physical robots, mechanical or electromechanical machines that are programmed to perform a variety of tasks. These tasks can range from simple, repetitive actions to complex operations that require autonomy and decision-making. Key aspects of robotics include 1. Hardware ** design and construction of physical robots, including mechanical components, sensors, and actuators. 2. Software ** developing the software and algorithms that control robot movement, perception, and decision-making. 3. Autonomy ** many modern robots are designed to operate autonomously, making decisions based on sensor inputs without constant human intervention. 4. Applications ** robotics is used in various industries, including manufacturing, healthcare, agriculture, aerospace, and even in consumer products like robotic vacuum cleaners and drones. 5. Types of robots ** there are different types of robots, such as industrial robots for manufacturing, service robots for tasks like healthcare and hospitality, and research robots used in labs and experimentation. 6. Challenges ** challenges in robotics include mobility, perception, manipulation, human-robot interaction, and safety. Automation ** Automation, on the other hand, is a broader concept that encompasses the use of technology to perform tasks with minimal human intervention. Automation can be applied to various systems, not just robots. Key aspects of automation include 1. Process control ** automation is often used in industrial and manufacturing processes to control machines, equipment, and systems, ensuring consistent and efficient operation. 2. Software control ** in addition to physical systems, automation also involves the use of software to control and manage tasks, such as data processing, report generation, and repetitive administrative tasks. 3. Efficiency ** the primary goal of automation is to improve efficiency, reduce errors, and increase productivity. It can lead to cost savings and faster task completion. 4. Examples ** automation can be seen in manufacturing assembly lines, home automation systems, and business processes like email filtering and marketing automation. 5. Integration ** automation systems often involve integrating various components, such as sensors, controllers, and actuators, to perform tasks without human intervention. 6. Human-in-the-loop automation ** some systems are semi-automated, allowing humans to intervene when needed or make critical decisions. Automation can be considered a broader concept, encompassing both physical and software-based systems, while robotics often specifically refers to the design and use of physical robots. These fields play a critical role in various industries, increasing efficiency, accuracy, and safety, and are key drivers in the ongoing evolution of technology and industry.